welcome Shreesha to the podcast. It's great to have you on today. How are you doing?
Pretty good. Excited for the podcast. It's a cloudy day here in Boston, but fairly warm for this time of the year. So yeah, so a good weekend coming up.
Nice. Well, yeah, it's nice to hear in Manchester. But just a quick intro to you. You're going to go through your background shortly,
Sure.
but you're associate director of machine learning at Best Buy, heavily focused on recommender systems, and it's somewhat of a good subject matter for the podcast. There's lots of people who listen from that kind of background, so I know there'll be lots of people interested in what you've got to say today. But I guess just to let people know at home, we're going to kind of introduce you to your career, what you've been working on, your background, kind of lessons learned in the first half of the podcast, and then it'll be an oral pod first. You're going to present your RecSys paper around what you did around XGBoost and some of the really great and interesting stuff on homepage personalization that you've been doing.
Yeah.
A little bit about your leadership experience and how you've got to where you've got to. And as always, with the show, just some future predictions and also discuss your book, which is super interesting. So, welcome, Shreesha, and would you just like
Thank
to
you.
talk people through your career history and how you got
Sh-
to today and introduce
Yeah.
yourself?
Yeah. Thanks for the brief introduction about myself, the overview of the topic. So, hello everyone. I'm Shreesha Jagadeesh. I'm one of the associate directors of applied machine learning at Best Buy United States. Yeah, so I briefly kind of lead the teams for personalization. I previously worked on like tech recommender systems, representation learning use cases, kind of moved around within different portfolio projects within Best Buy. So kind of like longer on how I got here. So I'm trying to think of where would be the best place to start, right? So maybe my master's degree in the University of Toronto in Canada would be a good place to start. So yeah, so I went to Toronto in the early 2010s to do a master's. That was in electrical and computer engineering. Back then, I was focused on making a career out of more on the hardware aspects. And so that just turned into an internship at a startup that my thesis supervisor had co-founded. It was called Chip Care. They made biomedical diagnostics for HIV patients in Africa. And then the core sort of intellectual property was to use like a single drop of blood to detect biomarkers in the blood, such as white blood cells, that would proxy for what is the status of the HIV patients. So my role was kind of like a jack of all trades, kind of all in one, both hardware and a bit of software analytics as well. So I was building like biomedical prototypes. I was a hardware engineer there, building some photonics devices like cameras, imaging equipment to detect what's in the blood and then also count those cells and then analyze it, right? So we were a pretty small company and yeah, enjoyed my time there. But over time, I realized that the hardware profession has a very long feedback cycle in terms of how quickly you can iterate on the ideas and get feedback from customers. So, looking at the overall sort of division between hardware and software, I realized that I think in the long term, it's better to be in areas where the feedback loop is much quicker so that the idea iteration cycles are much shorter. So I made a hard pivot towards more on the software side, and then within the software, I kind of took a liking towards more on the statistical data science aspects of things while I was at the startup. So yeah, so the subsequent job was at the consultant for Cisco, whereas working on supply chain data science and analytics use cases. So a very interesting use case was to like figure out forecasting for the right inventory levels to be stocking so that there's a trade-off between, excess inventory on one hand and on the other hand you have shortages and such. So along the way, I realized that while the data science part is great, I think to like really make impact, it's useful to have visibility and some level of need to also touch upstream and downstream systems. So that's when um, Ernst and Young, the role at Ernst and Young happened as well, where I was recruited to be a manager within their tax practice in Canada. And it was one of the first technical hires to do some digital transformation using data science techniques. That role was very interesting because yes, I did get the mandate to maybe go upstream and downstream, re-engineer the process, and do everything. But that also meant that I was wearing a lot of hats. So not only was there was a substantial amount of data science and ML techniques to be done, but there was also software engineering. So my team consisted of like software developers, front and back end, and also data scientists and a few product managers as well. So we had like a very interesting portfolio where we were building full stack software applications with the data science being the key IP. An interesting use case was a software as a service application where we took in client documents, financial statements, and then analyzed it using like a simple binary classification to determine whether or not a particular line item is eligible for a research and development tax credit. And once those tax credits are consolidated, the software application would then like create like a draft set of returns and then work with the accountants who then take over and then do some audits there. So that was pretty interesting. And then that's when kind of like towards the very end of 29 early 2020 is when like COVID hit and there was a little bit of dislocation in the job market. I was still employed in Canada, but around that time I realized that, the world being topsy-turvy might be a good time to like actually get married, settle in with my wife. So she was doing her graduate program at MIT back then, combination of PhD and MBA. So, but I was in Toronto, so I was trying to get to the United States. What's the go? So that's when Amazon happened. So, the Amazon role was basically working in the HR tech space,
Yes.
and yeah, the mandate was quite interesting because Amazon is obviously a very large company, and there's so many other business units and both internal and external sort of customer facing applications. And this was a purely sort of internal facing role where, unlike let's say EY, where there's a mix of internal and external, this was like, okay, you're mandated to build out um, data science capabilities that would impact other data science developers across the HR space.
Mm.
And it's surprising the amount of resources that a large, I guess, big tech company like Amazon can spare towards improving internal employee experiences. So that ended up evolving into something to not necessarily establish the feature store existed, but more like an evolution of an internal feature store platform, as well as the MLOps platform to sort of streamline how data scientists and machine learning researchers develop models and deploy them. Um, so that was one part of the mandate. The other part was actually helping bespoke machine learning models to be, I guess, going all the way from scoping to design, development to deployment. But I was still officially a product manager, not like a data science manager or like a machine learning IC role. So this was very cross functional. And then it was also a very interesting time because I think it was a very early stages of, what is considered at the data science PM. Like, are they a data scientist or are they a product manager? So I think one of the summers, 2020, yeah. So one of the summers I ended up having an intern who was a machine learning researcher to build like recommender systems and help match potential career growth ready employees with let's say other managers in other departments to be able to review. So we built up this POC, and that kind of got me kind of fascinated with recommender systems and personalization type of use cases. And in parallel, I was sort of advising. So this outside of my sort of day job, I was advising a friend over in India. He had gone back to India to basically build out a startup that supplies agricultural accessories and inputs to farmers in India, in central India. So think about like fertilizers and pesticides and all that. So he had the company's name is FarmCart. They
Mm.
have a physical store as well as like a website. And then he tapped my shoulder. It's like, hey, do you want to help guide? What are some of the best practices that could help maybe launch some of the analytics department and data science department within FarmCore? So I was like, sure, I'll give it a shot. And then kind of ended up helping them to hire a few key analytics and data science roles within the company. And that one of the data scientists and we ended up collaborating to build recommender systems for their omni-channel use cases, right? So, but it was fairly basic because it was still a startup. You don't really need like sophisticated models. So we kind of start off with like, collaborative filtering, matrix factorization type of use cases to figure out, okay, customers who bought this also bought that, user experiences. And that was a big value add to the startup. Yeah. Let me know if you want me to transition to Best Buy. I think.
Yeah, that'd be great. Yeah, yeah, talk through Breast Buy, and then it'd be good to, I think one of the great things about you
Yeah.
works across lots of different industries, and I'd love to just dive into that and the differences after. But yeah, talk through Best Buy. I think you've done some
Sure.
great stuff there from what you said.
Sure. Yeah. So right around like 2022, I realized that while I enjoyed some of the contributions that I was able to impact with Amazon, the peer group was amazing. Like I had a chance to work with Economist Nobel laureate Dr. Guido Imbens to sort of build up or get help in designing some of those models in conjunction with the other ML researchers in the team. However, in terms of the broader context of where I was situated in, I felt like maybe I had the opportunity to influence the company's strategic direction a lot more if I went to like maybe a mid-scale sort of Fortune 50 company. So that was kind of my reasoning to shift towards Best Buy, where there was this expansive mandate of helping drive recommender systems, personalization, and representation learning type of use cases and that would be very beneficial. It would be sort of like first in class for the entire company rather than just being yet another business department in the grand scheme of things. So that was kind of like the transition point in mid 2022 where, yeah, so I joined Best Buy and since then I've been there. We launched quite a few use cases. I won't get into technical details on all of them, but there may be some relevant things such as the homepage personalization for which I published a paper, which we can cover later on.
Yes, that sounds great. Something you touched on there, Best Buy, obviously a mid Fortune 500 company, and Amazon. You mentioned you were surprised at how much resources they could dedicate to HR tasks. To me, they're both personalization and recommendations at scale. What would you say the main difference was doing, if you can say, doing recommendations at Amazon compared to Best Buy, who, have also got, I would say, quite a lot of resources?
Yeah, yeah. So I think the the domain is also quite different. I think there's multiple distinctions there in addition to the company itself. The sheer fact that one sort of like an offline use case versus an online use case makes a difference. So in any retailer, you have a situation where customer lands on the website or the app, and then the system has to make predictions in real in most of the cases, and you could still catch some of those predictions. However, in the case of like internal sort of HR tooling, you don't necessarily have that constraint. You can do a lot of like batch predictions. Um, that's not to say real time inference won't make a difference, but you could probably get away with maybe slower SLAs. The other consideration is the data privacy piece as well. Like when it comes to helping internal employees on certain career trajectories, the data privacy aspects become super critical. There's there's a lot of data that you're not allowed to use. I won't get into specific details about that in Amazon, but in the case of retail, I think it's a little bit more relaxed, especially when it comes to like clickstream and browsing behavior. There's still some sensitivities around like personally owned information, even in the case of retail. But the vast majority of like clickstream events, search events, browse, and so on, add to cart purchases, there shouldn't generally be constraints in the retail industry. So
Yeah.
that makes model performance generally main determining factor rather than many of the privacy considerations.
Cool. Okay. Interesting. And I'm moving on. Like I say, you've worked across HR tech, biomedical engineering, now retail. What would you consider, the fundamental machine learning techniques that have stood you in good stead that are transferable across industries? Because some industries doing well and others not so well at the moment, and people looking to move around. What do you consider to be transferable?
Sure. I think taking a step backward, I think this is a very important question to be able to sort of introspect on for any sort of person in terms of their career opportunities out there. Like what are the differentiating factors do I bring to the table? And I think the key driving aspect is really understanding the customer problem, no matter which domain you're in or which sort of technical skills that you have. It could be software engineering, product management, machine learning, whatever, finance or whatever it is, right? Um, so really trying to get into the heart of what the real problem is rather than the stakeholders or the business team's representation of the problem. Many times they might actually contradict. So and as you go along, you start realizing that not all the requirements are mandatory. Some of them are mandatory, some of them are nice to have, some of them are actually not even requirements. Some of them are assumptions or speculations that the business thinks is useful, but it's not usually backed up by data. So really getting to the heart of the problem, how do you frame it? What happens if you don't build a solution? What's the baseline? So thinking through that. Specifically in terms of machine learning, I think fundamental sort of curiosity, stream and downstream processes and technology stacks that are complementary to the model itself is critical. I think there was a very interesting 2015 paper by Google. It's called The Hidden Technical Debt in Machine Learning. You might have seen that infographic. So there's
Yes.
like so many other modules. It basically depicts an ecosystem of different technology stacks, not technology stack, like different modules in the machine learning pipeline. You got like feature ingestion, feature processing, feature engineering, data quality monitoring, and then the model itself is like this tiny, tiny little rectangle, the overall sort of architecture, right? The where I'm getting at with that sort of process is like you have to really the machine learning engineer, you have to really understand what is the source of your data. Where does your clickstream events come from? Or where does your supply chain data come from? What generated it? Is there any sort of like interference in the processing that might bias your samples? Like, are you only collecting clicks or are you only collecting one type of data versus the other? And then same thing with like the downstream. How are your model predictions getting used? In the case of recommender system personalization, it's most likely your model predictions are directly put in front of the customers, right? You have a front end that renders your ranking somewhat, maybe filters it away for duplicates or something, but in general, there's not a lot of interference in the model predictions before it reaches the customer, but that may not be true with many of the backend sort of internal tooling or other types of non-customer facing ML use cases. So think through on how the downstream integrations happen. Are there post-processing layers that might invalidate how you generated the result? So I'll give you an example of there was an interesting use case where the marketing team was like, well, we really need model explainability, right? And then I mean, if I was a junior engineer, like looking back at myself 8 years or 10 years ago, I would be like, sure, I'll give you a feature importance. But now I'm like taking a step back. Why do you need model feature? Like, why do you need model explainability? What does that help you with? Right. And they're like, well, if I know which attributes in the model are helping to generate those predictions, then I can like tweak something and then like re-engineer the system to do that. But I'm like, hold on, I don't think you need this extra two-step process to get feedback on feature importance if and then try to like fine-tune it manually. We can do that in an automated system by retraining the model by looking at the same feedback data,
Yes.
right? So you don't need an extra step. So I was just using that as an example to say, really understand your downstream and upstream process. The third, I would say, common attribute is like really keep learning. Whatever field you pick in, try to go really deep into it. Could be computer vision, natural language process, like NLP, and recommender system personalization. The surface level knowledge is becoming a very much of a commodity these days because anyone can go into ChatGPT and like you can literally say, "Hey, can you build me an algorithm that reflects what's in this paper?" That is possible today. I've tried it even for very advanced papers, and it gives me fairly reasonable Copilot. Copilot gives me like fairly reasonable Python scripts that could replicate a research paper. So yeah, so that those would be my sort of like three main pieces of advice for ML engineers looking to sort of transition.
Nice. And you've kind of already answered this in that question, but with AI and co-pilots, it's becoming a little bit harder as someone junior or mid-level to break
Yeah.
into the first role after internship. What piece of advice would you give to them to become an A player engineer or A player research scientist? When they're competing against potentially a co-pilot or AI in the first instance, or teams are now a little bit smaller because
Yeah.
they're more efficient.
Yeah, that's a great question. I think that is definitely the case that in the last couple of years, the job market has become extremely competitive for early career employees looking into break into the profession. I mean, if this happened like 10 years ago when I was entering the field, I would have been in a lot of trouble myself. So I kind of have sympathies towards the newer generation of folks who are entering it. Mm, Of course, like take my advice, whoever is listening, with a pinch of salt. But I think with the speed at which AI engineering and ML engineering is moving, I think paradoxically, what we need to do is look for the most like highest signal to noise ratio content available and try to like learn it rather than like spreading yourself like way too thinly. I think that aligns with many of the guidance given by much more senior members in the ML community that I've heard as well, right? I don't think they're all keeping up with the pace at which this is advancing as well. Specifically for like more tactical, I guess, areas that could improve the profile, I would say like build a lot of things, right? Like the barrier to entry to building is very low today. Like you could mock up something very useful in the span of a few hours if you have access to Copilot, and maybe like other sort of coding tools. But what matters to employers is like, are you able to think end to end, right? It's pretty easy to like create a or replicate a tutorial, but can you go like one step further and change a few like design choices? Do you actually understand the system you're building, right? Can you tweak a few things? Tell me what you learned from those things. I think that's what would differentiate yourself from the the massive amount of people who are just like, replicating a tutorial and then putting that off as an experience in the resume.
No, really good points, and I'm sure people find that really useful. Moving on to retail personalization and kind of some of the marketplace dynamic
Yeah.
stuff you've been doing at Best Buy. Best Buy obviously a huge retailer. Um, what unique ranking and recommendations, problems and challenges come with a company of that size and such varied products, I guess, that you're dealing with, and across such a large geography as well.
Yeah, definitely, definitely. Again, I'm not a spokesperson for Best Buy, so these are completely my personal opinions on
Fair.
the nature of the problem space here. So I can talk in general about the nature of problems that retail companies in general face, right? Versus, let's say, the common types of personalization or recommender systems experiences you might have seen in social media companies like Facebook news feeds or Instagram or Snapchat or something. So I think especially for social media companies, you have a massive amounts of content being added every day, which means that cold start problem is very much front and focus, right? Like you need to figure out a way to get the high quality content in front of the customers as quickly as possible. In contrast, I think retailers also face cold start problem with respect to new products. but it's not as severe as, let's say, TikTok scale. Like you're not uploading billion videos every month, every day or something in most retailers, right? There's no videos, but the analogy would be maybe the products themselves, right? The turnover in the catalog is nowhere in that scale. It is still substantial enough to warrant its own thing. So instead, what ends up happening is, I think the emphasis is more on like enrichment. What do we know about the products, right? Is there a way to like augment the quality of the products with additional sort of enrichment data? So those are some of the challenges. It's an open-ended challenge. It's not like, yes, we enriched it and now we are done. It's more like, okay, we have some like, I don't know, TechCrunch articles or some other like blogs. Is there a way to like bring that insight into what we know, right? So those will be some of the frontiers. I don't know if it's a solved problem in other companies as well. But so that would be on the product side. In terms of the customer side, I think it's um, and we can talk about it a little bit on the homepage when we get to the homepage personalization, right? When it comes to the customer side, you have a situation where there's both like logged in customers and visitors who are unrecognized, right? Like, of course, if a customer is logged in, sure, you know a lot of information about their previous purchases and browsing history, clickstream history, preferences they might have set it in their accounts, their email clicks, and a lot of other information. If they're not logged in, then you're kind of like, okay, what contextual information should I be relying on to make more accurate predictions? And that's generally true with any retailer in general. Like if you don't have customer logging in, then you have a much more limited set of attributes and signals, features to work on to make the model predict accurately. Um, Kind of along the customer lines, right? So you also have the when the customers are traversing multiple stages, or like homepage search and the product page, and then maybe accessories page, and back again to like deals page and so on. How do you ensure you're not like, how do you strike the balance between content that might be perceived as being duplicative versus it's an intentional, there's a reason why you're showing a few things repeatedly, right? So
Yes.
those are some of the sort of like the frontier challenges, right? Is there some sort of time invariant sort of model that can look across the customer journey, or is it like a point in time prediction that is sort of stateless model, right? Like those are some of the sort of frontier challenges. The more practical challenges are like on the data side. So imagine a customer goes from like the home page to a search page or a product page, right? Can we or is the data infrastructure fast enough to know those real-time signals of what happened in the previous pages and feed that back into whatever internal pipelines into the predictive model by the time the customer goes to the next page, right? So those sort of like real-time event architecture would be sort of like some of the more practical challenges, even if you're doing sort of like point-in-time predictions without being stateful ML models.
Cool. And yeah, the next part I'm particularly excited for. I know you placed a static homepage with an XGBoost model, and it's a accepted RecSys paper. Yeah, do you want to just talk us through that, some of the challenges you faced and payoffs, and yeah, over to you.
Yeah, sounds good. Sounds good. Yeah, so the conference for which this paper submission was made is the ACM RecSys conference in Czech Republic later this year in September 22nd. So the industry paper title is Retail Homepage Personalization of Heterogeneous Content Using XGBoost based ranking system. So yeah, so we in that paper I talk about some of the ways like homepage heterogeneous content personalization is a little bit different from, let's say, a newsfeed ranking on Facebook or other types of like similar content recommendations. So allow me to explain. So in the case of, let's say, your what would be a good example? So imagine you're like looking at restaurant recommenders or something, right? So your content is generally all restaurants, and then you have access to the item information. In this case, let's say restaurants. And then you can set up a homepage where you can dynamically say, okay, the best restaurant should kind of go on the top, and then within that carousel, the best restaurants in that carousel should be on the far left, right? And then kind of like downwards, the higher the quality, higher the position on the page, the higher the quality of the recommendations would be what would be expected. However, in this case, the problem framing is slightly different in the sense that there are separate business domain models, other ML models or heuristics that generate sort of within carousel recommendations. Then the question becomes, then what is the purpose of the homepage model? The homepage model is more like it's placing it vertically on the page, as well as we ended up having like a hierarchical nature. So in addition to like a concept of like a carousel, we have like nested carousels. So it's more like if you open your Best Buy app, it's pretty obvious. So there are what we call as stories, which are basically content blocks that conform to a particular theme. So continuous shopping might be a theme, and it will have your basket, it will have your saved items, it will have recently viewed items, for example. But each of them is a carousel on its own. Recently viewed will have its own set of SKUs. Saved items will have its own set of SKUs, and your cart basket will have its like own set of SKUs. And that itself will be sort of like ordered somewhat, right? Like chronologically ordered or some heuristics or ML model based. And then, so now the model, the homepage personalization model, to decide which of these three carousels, the recently viewed, the in cart or saved, would have to come first, second, and third. And then where on the vertical layout of the page does the entire continuous shopping would come first. So it's it's not necessarily trivial, because I think a common way many people would tackle, let's say, recommendations problem is to do a two tower approach, right? You have a content tower and then like a customer tower. The content tower, you feed in all of the item attributes, and then the customer tower, you have all the customer profile and engagement information. We have customer profile and engagement information, but your content tower is a little bit different. We can't really say, okay, these are just items. These are not items to be ranked. These are like carousel. So it's kind of like one level higher up. So we didn't really approach it using a two tower model. Instead, we said, okay, let's try the most powerful sort of formulation of traditional machine learning using, the gradient boosted decision trees and its variants. So we kind of landed upon XGBoost 2.0, and the paper goes into details of why we believe XGBoost is suitable for the specific problem that we attempted. So yeah, so we experienced a huge increase in engagement. I mean, this was in the first version of the model. We had actually an ML-based versions prior to even the XGBoost, which also experienced increases in engagement. But this was the one that actually demonstrated increases in like some of the revenue metrics the business cared about. And so we decided this would be the perfect time to like publish a paper as well to sort of talk about some of the aspects. The other part
Nice.
that Cooper talks, go ahead.
Yeah, I was going to say, I'm sure it's summarized in the paper, but what would you say, at a high level, the key challenges of implementation were from replacing the static page to this model?
Sure. I think it's less about the I think static page is a misnomer. There was still some element of heuristics driven personalization before, but it wasn't necessarily an ML driven, fully ML driven personalization. So I think this is actually a very good question, because reflecting upon the journey and this will be true with any sort of new user experience that is getting launched. You don't have training data. When you first launch any experience, your customer behavior is so radically different. You cannot use the historical experiences engagement feedback as the basis for training your new version of the model, right? So I think that was the critical challenge that we faced when we moved away from the old experience to the new experience. And this would be true for any placement, right? Not just homepage, like search or product page or like other. And this is not just about Best Buy. Like any retailer or company would have the same challenge. So then then it's more of a internal sort of development challenge. If you don't have training data, then what are you building, right? But you still need a model. So what ended up happening last year was we said, okay, we're going to develop our code base. We're going to develop training pipelines and serving, assuming this data schema is what is going to be generated when the data actually starts flowing in, right? So we have to be really thoughtful about how do we sequence our work so that we can have all of the sort of skeleton code and skeleton sort of pipelines ready. So when the homepage turns on, the model starts learning immediately, right? So there's a little bit of like exploration exploitation, which we did a little bit of reinforcement learning before that XGBoost model. But so that's kind of like the critical aspect of any new experience transformation. And then specifically for the homepage model, I think the biggest internal challenges is more of an engineering challenge rather than an algorithmic challenge. It's around feature store and how do we make sure that the overall latencies when we are calling in like features from feature store doesn't exceed our SLAs. So what I mean by that is like if you have hundreds of like features on your customer, you can sequentially call them because the feature store API might store them in like different sort of not tables, but different APIs basically. So you can sequentially call them, get the data, and then the next one get the data because that would like exceed the latency SLA. So you'd have to parallelize your call. That's number one. And then you'd have to join the data after you get back. It sounds fairly trivial, but on the engineering side, it's non-trivial because you might have like race conditions and so on. So the other aspect is around multi-region deployment and like co-location, right? So a user making a request in, let's say, New York, their request should not be routed to like all the way towards the West Coast and then back again. So that would like breach your SLA requirement. So you have to be really cognizant about where is your request traversing the network. So we ended up doing multi-region deployment. And then the feature store itself is sort of like co-located within the model endpoint so that the network latencies are as minimal as possible.
Cool. And yeah, I think but super interesting, by the way. I think you were just about to go on to some of the payoffs that you got. It sounds like you worked really hard. And what results did you kind of notice from once you got it up and running?
In terms of the engineering results or like the customer benefits or company benefits?
I think let's go into all three. I think all three super relevant.
Sure. Yeah. So I think in terms of the engineering results, we managed to squeeze out latencies from the system, and it's like well within the 100 milliseconds overall latencies. Um, and in terms of the customer behavior, we did notice like double-digit increases in the homepage engagement, which is quite a lot relative to what it was before, and also an increases in like kind of like we have our own sort of internal revenue metric. It's related to what we extrapolate to be the increase in basket sizes as customers shop, right? Because and that's one of the things that perhaps I might have missed earlier on when I explained some of the differences between retailers and let's say social media companies. A lot of the high value retailers, the frequency of customer shopping is much lower than, let's say, you're a grocery company or a social media company. People are not coming back like every day to like buy a new thing. They might buy an iPhone like once a year or a laptop like once every couple of years or a washer dryer, right? It's not like, okay, you're coming back next week. So some of the business metrics are more like long-term, like sort of forward-looking. Okay, if we extrapolate this trend, what do we anticipate the business benefits to be if this trend keeps up?
Cool. Okay. And getting a RecSys project like this
Yeah.
off the ground, I imagine certain costs associated to it. Some of the guests we've had on in the past really gone deep into A/B experimentation, but from your perspective, and I guess this is not restricted to Best Buy, more, you've worked at lots of different enterprises. How do you frame, potentially a high costs buy into projects like this, and what kind of initial A/B tests could you do before you kick the projects off, or do you do once you've started?
Yeah, yeah. So I think, um, well, first of all, I think it's a combination of top down and bottoms up approach, in the sense that if you have leadership buying ahead of time that yes, machine learning, AI driven experiences are going to be beneficial to the customers or any other sort of internal goals, then that's the best position to be in, right? So it saves the team a lot of effort to be like, doing some education of, okay, why is personalization beneficial, right? So, but let's assume that is not necessarily the case, and there's some, let's say, pockets of awareness, but not necessarily fully prevalent in the company. Then the situation would be sort of like you'd have to invest. It's not going to be like, okay, I have an idea, I'm going to propose this, and it's going to get approved. It's a long term plan. You'd have to slowly start bringing in people and stakeholders along the journey. For example, a common pattern in recommender systems is to basically do like a multi-stage, right? So you do like a fast retrieval stage using like a two-tower model, and then like a ranking stage that is much heavier model, but also incorporates a lot of other signals, and but she processes fewer like items or customers to recommend, right? So, but what is that multi-stage recommender system? People are generally not aware of it outside, specialists in recommendations and personalization. So there's this element of education in place to kind of explain, here's sort of like the best practices in the industry, and here are the reasons why you need like a two-stage approach. But you don't necessarily need both stages to be effective. So one of the things that I did in one of my previous projects was, yes, even though two-stage is beneficial, let's start off with just one of those stages, demonstrate value, and then start like tacking on more complexity to it, right? So kind of like an incremental sort of evolutionary approach to how you sequence the projects becomes important. And then in terms of the A/B test itself, I think it goes back to what is considered important by the business. So allow me to explain. So imagine a business stakeholders comes to you and say, hey, I wanna introduce this new loyalty offer on the cart page when people are checking out, and I want to increase revenue. So let's say that's kind of like the problem statement, right? And then, I mean, if it was a junior ML engineer, they'll be like, sure, I'm gonna build you like a binary classification model that can take in some consumer signals and then recommend or not recommend that loyalty offer when they're checking out. But I think way, way, way before that, like try to really understand the problem even before you go into an A/B test mode. The reason is the hidden in that request is actually a very contradictory set of objectives that would need to be surfaced ahead of time. Because, for example, if you introduce a loyalty offer, you have to have the product intuition to be able to say that you're introducing friction into the customer experience, and therefore your conversions will actually decrease, not increase. So, and then you might get into a debate with the product manager or business partner saying that, well, I meant long-term conversions, not short-term conversions.
Yeah.
By doing a loyalty subscription, the customer is now able to go in and shop more often in the future, and therefore their future conversions will be increased, which is fine, but that's a different problem formulation than what was stated earlier. The reason why that's important is there are some metrics that you can measure in a 2-week A/B test, but there are some metrics you cannot measure in the duration of the 2 weeks. Like the long-term sort of benefits from loyalty would not be observable in a 2-week experiment, right? So the most you would have is the short-term detriment to immediate conversions, because you're introducing more friction in the pop-up, right? So those would be some of the considerations. And then it becomes like a question of going back to your earlier question, how do you demonstrate value? Sometimes demonstrating value would itself require some very thoughtful experiments to collect data that would validate or disprove your initial assumptions. So just extending the same example a little bit, a simple way to experiment would be do a A/B testing where the control group never receives any recommendations, and then the treatment group all of the people receive a recommendation. There's no model. Like just throw all the recommendations to that people and see if there's a detriment, right? Or an improvement. That will kind of give you a benchmark of, okay, here's the maximum possible loyalties you could get for a given cohort of customers when there's no model in place. And then you can kind of like play around with the trade-off. Okay, for this amount of loyalty offers being subscribed, here's a detriment in conversions that I get. So now you can start playing around with that trade balance and then working conversations with your leadership saying, we're going to build a model that will improve precision. But that precision also means that you'll get fewer recall, which is you're not casting a wide net to do everyone. But if you don't want precision, then you should not even be asking as a model because, you can just show that loyalty offer to everyone. So I think there's various, depending on the use case, there's like various ways to frame the value. So some of them require, socializing. Some of them might require like experimentation to determine what the maximum possible value and so on.
Yeah, but I mean, what super insightful. I think what I take from that is you've had really good, obviously, foundations in machine learning, but being able to translate it into product and the business, and also, it all intersects at your business acumen. Yeah, I think really interesting. I think moving on to the next part, we spoke previously before the podcast about some of the work you've done using representation learning and how that's come to help you with more traditional ML methods and now Gen AI. How are you using representation learning to kind of add value to the retail
Yeah.
shopping journey?
For sure, for sure. I think representation learning has been around for at least a decade now, right? I think in terms of, or maybe even longer, because the original sort of collaborative filtering model, like fundamentally, it turns users and items into some sort of an embedding space, and then you try to find distances between them. Now, like taking that concept along, I think the wind of deep learning, or I should say the popularization of deep learning techniques to generate embeddings basically means that you can convert a product, like let's say in the traditional sort of data science world, you would take a skew ID, the brand, category, price, all of the other information about that product, and then build, and then maybe some other, something similar for the customers, like, their profile characteristics, their clickstream behavior, and then do manual feature engineering, and then feed that into a supervised model, and then click or no click, like a classic CTR prediction. However, when you're talking about it at an enterprise level, the value proposition for representation learning is more around, do you want to not prevent, but do you want to centralize the product understanding and customer understanding so that multiple teams are not duplicating the effort, right? You don't want, so what ends up happening is each team will be working on a very specific problem, like cybersecurity fraud, or, the loyalty subscription, or like recommenders or ad tech use cases. But fundamentally, you're still working on the same customer, right? And then your product catalog is still the same catalog. But if each team might do feature engineering ever so slightly differently, right? So is there a way to like have a common set of agreed upon patterns ahead of time so that it saves everyone else time in the future from doing feature engineering? So that's kind of like the value proposition for doing any sort of like user modeling and item modeling. And then more tactically from the reusability perspective, what ends up happening is you have a central team that creates product and item embeddings and then stores it in a feature store so that other teams, other ML teams can consume it for their domain specific use cases, right? So where I think the literature has sort of evolved in the last decade or so is that there's some very popular approaches to using variations of, let's say, word to vec type of approaches, prod to vec or meta prod to vec, to represent products better. And then I think recently Facebook also released a paper called HSTU, where they're using like transformer-based approaches to really understand their customers. So they have like an LLM-based recommender systems. So it's kind of like getting to the intersection of the more traditional sort of representation learning sort of evolving into LLM-based approaches. Mind you, the LLMs that I'm talking about are not the generative AI, so they're not like the chatbot type of conversational LLMs, but more like transformer-based approaches in general.
Okay, yeah, that's super interesting. A lot of customers we're working with certainly moving towards more LLM based
Yeah.
recommenders. Um,
One more thing that I want to add there is like if you really want to use the power of generative AI to understand customers and products more, you can actually literally feed in, let's say, clickstream data into an LLM, into a generative AI like Gemini API or ChatGPT API.
yes.
Let's get the question: what is a customer trying to do? You can summarize it that way.
Oh, really?
It's how effective they are, but it's possible.
Yeah,
The constraint is more to do with the cost and latency because you generally cannot do that in real time. And then if you try to do that for like hundreds of millions of customers every other day, it's going to be problematic.
yeah, fair enough. All right. Well, yeah, that concludes the personalization part of the podcast. I think some really insightful points you made there, and yeah, thank you for sharing. I think moving on to the last couple of parts, this more about experience and leadership, and something you've got plenty of. You know, more leadership in enterprise level organizations that you've worked at. What would you say are the main leadership principles that have allowed you to be successful? And I hope you don't mind me saying, but it's like you've moved up pretty quickly. What has
Thank you.
got you there?
Yeah, I think I've covered a couple of those points before, but just reiterating those, right? I think customer obsession is a big aspect of what I personally think of in terms of leadership principle, like really understand who your ultimate customer is, what business problem are being solved, and go upstream, downstream, right? And then trying to figure out if it's not just about like me being customer obsessed. It's about imparting that sort of perspective upon all of the other developers in the team as well, right? Like, how do you ensure that? How do you empower everyone else in the team to also focus on the customer problem rather than a specific stakeholder you're trying to solve? Right? So I think the corollary of that is it also moves people away from obsessed with a particular modeling technique, right? Modeling techniques are basically ideas. Some may work, some may not work. It's okay. You can move on to other modeling techniques or data approaches, right? But falling in love with the problem is actually more critical than falling in love with the solution. I think that's kind of like
Yes.
the phrase that I would use. The second aspect that I would say is kind of like really deeply understand what your team is doing, right? So there's one element of empowering and delegating to the team where they're good at. But you'd also need to really understand what each person brings to the table, right? Not everyone is going to be like a unicorn of, okay, they can do like, feature engineering or modeling and then model deployment and then optimizations and monitoring. But you have like a symphony, like an orchestra, like each person is a specialist in certain areas. They may be able to do other areas as well, but they may not necessarily be good at, right? I guess a complementary to that idea about diving in deep into each of those things is it also helps to speed things up when projects are on a very tight deadline, right? So I think even like 5 years or maybe 3 years ago, it was very common to say, oh, most machine learning projects do not make it to production. Personally, I don't think that's true anymore. I think most machine learning projects these days actually make into production. Not only that, many of them go into production in a span of like 2 or 3 months even. I've seen some extremely fast execution in several of the companies that I worked for.
What
Yeah.
would you say is the biggest difference from a lot of projects not going into production to now?
Yeah.
More are.
Yeah. So digressing a little bit there. So you raise a very good point on what differentiating attributes. My personal observation is that many of the projects that do not end up going into production have not been de-risked at the very beginning. So one sort of hypothetical example about the loyalty offer, right? Like really honing in on what your evaluation metric is. So it's either a problem with the right data not being available, the evaluation metric being incorrect, or the downstream um, consumers of the model outputs not being ready to actually consume it. The other things that I've seen are infrastructure issues. Can you really run the model at a very stringent latency, or is your latency going to cause you issues? So much of those things can actually be de-risked ahead of time, or at least in parallel to your model development. Right? These are not like unknown things. Of course, people have faced these challenges in the industry, right? So sequencing the work in a way that allows projects to be de-risked along the way is going to be a critical attribute to ensuring projects are successful. And that's where the diving deep into your the work that your team does and everyone else is doing to help support your team is very critical. Like as a leader, you have to be hands-on in terms of at least knowing what your team does, even if you're not necessarily the one coding out every single module in the pipe.
Okay, yeah, Ben, thanks for sharing that. I think he interrupted you a little bit, so apologies for that. But in terms of leadership principles, is there anything else you'd like to add in terms of what's helped you? You mentioned, I think, before we left off about just knowing what your teams are doing and strengths and weaknesses.
Yeah, definitely. So I think in terms of continuing on the thread of leadership principles, like really respecting your product and engineering partners who are helping out, I guess complementing the machine learning team's strengths would be super critical. I mean, a great like sort of data engineers and platform teams are sort of like the unsung heroes of those who support the machine learning models from failing, right? So the amount of effort that goes into data quality is unimaginably complex. There's like so many clickstream events and offline data all being like joined together, some massive ETL jobs that are running. So those are very thankless jobs. And when models succeed, many times those data teams and infrastructure folks do not get the credit for, right? So like how do you kind of like keep them in the loop, make them aware, share in the success, right? So it's more like a collaborative thing. And that would benefit future projects because now they're more open to sharing the thoughts. Hey, I don't think this data pattern that you're trying to do is actually going to be beneficial. But instead, what if you do this, right? So it's kind of this collaborative nature there. Um, the last thing that I would say is sort of like try to be as curious as possible about the upstream and downstream. And I kind of mentioned that in the earlier stages as well. In sometimes stakeholders are kind of shocked that, oh, I thought you guys are machine learning people. Why are you guys interested in all of these other aspects? But it's important because if the machine learning model is used wrongly, it might not work the way you would expect, right? So just purely selfishly from ensuring machine learning model, I actually have to be sort of selfless and understand everyone else, right? So empowering the team to really be curious about everything else around them is going to be critical as well.
Oh, again, super interesting. Really like how curious you are about the customer and the problems that you're solving. I think, yeah, it's definitely unique. In terms of, we kind of touched on this at the start of the podcast, but traits and things that you look for in engineers or researchers to that kind of round out your team. Are there any kind of
Yeah.
fundamentals that make people good engineers or researchers?
For sure, for sure. I think in the last 6 to 9 months, there's been like dozens and dozens of interviews conducted. So a lot of these are like fresh in my memory. So we were like massively scaling up our Best Buy India office in Bangalore. So interviewed like multiple director candidates, senior manager, senior IC, staff principal. So I think it really depends on the level at which the candidate is interviewing for, the whether they're interviewing for like a research role or an engineer role, right? And then or like an IC role or a manager role. I think these all make a difference. So like of course as a senior IC or staff kind of person, you have to be really, really good at writing good code, efficient code. Those are like fairly strong fundamentals there. And I think definitely another critical aspect of being like a researcher and IC is being able to sort of link the solution that you're proposing with sort of like industry standard. So that's the problem that you're trying to solve, right? Like how does your solution, how is it unique, or how is it building off of what other people have done in the industry? Because if you're trying to propose a solution that doesn't exist at all in the industry, that's kind of odd in the sense that where did that idea come from? How do we know that it's going to work? Right? So it's kind of, you're not necessarily, most of the times you're not necessarily needing to innovate on the problem. Like many of the problem patterns already exist in the industry. It usually means that the person has not done enough literature review to really understand the problem space. I'm talking about like technical literature review, right? And then also we're trying to see how their solution maps to the problem that you're trying to solve. Like, are they proposing a problem because they want to like, or did they work on a particular problem because they wanted to like pad up their resume, or is it an actually a good problem or a good solution to the problem they face, right? Like, what are those design choices? What are those loss functions? What are those evaluation metrics that are bespoke to your problem that you believed you made the change, right? So
Yes.
trying to getting a sense of their contributions to this versus just running on autopilot, and they're part of a bigger team.
Yes.
So as a manager or like a senior manager candidate, I think the emphasis is now a little bit different in the sense that how did you empower your team to be productive, right? Did you work on the most fun parts of the projects for yourself, or did you work on the things that are the highest value add for the team, right? So those can be like different things. Sometimes the highest value add may not be the fun to do, right? So you have to sort of understand, is this person is a team player, or are they trying to be yeah. So those are sort of things that you'd want to be looking at a manager candidate. But even more importantly, like as a researcher, you would want some, specifically for recommender systems and personalization team use cases, you would have to have worked on online deployments, um, because the intuition that comes from building a model all the way to production and then seeing that, oh, the data that I retrieved, that the serving pipeline gets in the inference, the API, feature store API, is not the same as what I saw in training. There's a train serve skew. That level of insights do not come easily for people who have only worked on batch inference job. And this is true for ML engineers as well, right? The online serving use case is a whole another ballgame compared to any sort of batch deployment. So working at scale, working on online deployments, rather than just a batch inference process, those are some like critical factors. And you might have seen that in your hiring spec as well for recommender systems candidates.
Yeah, definitely. I think recommenders at scale is totally different
Yeah.
to anyone who's done it in a startup or
Mhm.
otherwise. So cool. I'm looking to the future. I know you've got your book coming out, which must be super exciting for you. I imagine.
Yeah.
Do you want to just share what it's about and what you're discussing?
Sure, sure. I think so. Yeah, just for context, right? So I kind of, when I first started down the path of, recommender systems personalization, there were quite a few like introductory books on this topic. And of course, like tutorials on collaborative filtering, content filtering. But I didn't really, at least when I started my sort of journey in recommender systems, there weren't really a lot of good sort of like uh, books specifically focused on practical stuff, right? End-to-end recommender systems. There were end-to-end ML engineering books, like Chip Whelan had written a fantastic ML engineering book a few years ago, where there's a lot of best practices for any sort of machine learning problem in general. So what if there was a book around recommender systems kind of in that sort of caliber, right? So that kind of got me thinking, is there a way in which future entrants to the field of recommender systems personalization do not have to go to the journey of, cobbling together conference videos, a few blogs and a few like papers out there. Rather, it's all like consolidated in one place. So that was
Yes.
kind of the motivation for kind of starting to write this book. And so far, I mean, it's I've always kind of debated on what's in the book versus what I just refer people outside. But so far, the structure of the book is like, rather than starting off with the theory of, oh, okay, this is a collaborative system model, this is like a content filtering. I think many of those techniques are starting to show their age and perhaps not as relevant for industry enterprise recommender systems anymore. Those are good to know, but not necessarily how things go in production these days. So instead, the flow is more like, okay, here's like an end-to-end sort of RecSys architecture in the modern. Yes, there's some introductory collaborative filtering, but that's more like the history of recommenders. And but instead, it's more like, let's say the famous Eugene Yan's blog post on here's like multi-stage recommender systems, and here's all the different components. And then you kind of like dive into each stage. So each of the book chapters focuses on a different part of the recommender systems pipeline. So we are talking about model training infrastructure, right? How do you work with the feature store team to make sure that you have the training data in the right format necessary to build a supervised model? That is something that not a lot of people cover. Like, so I'll give you a classic example of like a gotcha. So I have seen use cases where people say, oh, we have lots of data. We have lots of historical training data. But when you start going into their databases and you realize that what they're saying as data is only the people who have clicked on a particular item. They do not have impressions data. They do not have they have not set up the front end clickstream events ingestion for customers who came upon the page, viewed something, but did not click on it. It doesn't exist. So it's very hard to like structure a supervised problem if you don't have partial data, right? But think of that. So coming back to table of contents, right? So it walks you through the journey of building the recommender systems pipeline end to end, and also diving into the specifics of particular technology stack, right? So if you talk about training data, so you need BigQuery, right? And you need some sort of like a feature store wrapper around BigQuery. Then that people ask, why do I need feature store? Well, then you have the problem of train serve skew. You need consistency between what's in training and what's in survey. And that's not a lot of things that outside of online inference, perhaps it's very prevalent, the concept of train serve skew. Then you talk about like the actual modeling, two-tower model, ranking model, graph neural networks and all that. And
Yes.
then you talk about like A/B testing. And this is a critical area that a lot of people are not fully aware. They think that, oh, we'll just delegate it to the platform teams who will implement the A/B test. But unfortunately, if you it's much easier for an ML engineer to understand a bit more about the statistics to make sure the entire experiment runs well, rather than for the platform teams to understand how your model's working. So that's kind of like the motivation to sort of nudge industry practitioners to learn a little bit more about the A/B testing procedure. And then lastly, it talks a lot about like how you can make the development lifecycle scalable across the enterprise. And this is more catered towards managers, senior managers, directors, leaders in the company who have, okay, they now have a portfolio of products. Great. People can build their model all day long. That's not the problem anymore. But instead, you cannot be building a model for each bespoke use case. How do you make your team more efficient? And that's where representation learning, embeddings, product embeddings, using LLMs to enrich data, all of that comes into the picture, right? How do you set up centralized data assets using machine learning techniques so that other ML teams in domain specific use cases would benefit? They kind of like, so that's kind of like the end to end sort of structure of this book, which I hope to be complementary to all of the other sort of fairly
Yes.
soft blogs and tutorials out there, but may not necessarily get into like the enterprise recommender systems development.
Okay. Yeah, and this may be an obvious question, but who and what kind of people do you think it will benefit the most?
Sure. I think the first half of the book is, or the first, I would say, two-thirds of the book is mostly catered towards, the hands-on ML engineers, researchers, developers who are coming in, who are already, let's say, in the field of data science or machine learning for several years. They built models. This is not their first sort of ML model by any means, but now they want to get into recommender systems and they want to accelerate their journey. So that's kind of like the main audience for this book. And then the second, sort of like not the second, but the last one third of the book is sort of, as I mentioned, catered towards leaders who lead recommendation systems or personalization teams. And they're technical leaders. They can
Yes.
understand what's going on, but they may not necessarily be familiar with the nuances of what goes into recommendation personalization. So,
Oh,
so
cool. Sounds really exciting. What's the planned release date, and where can people find it? Lastly.
yeah, I'm still working with publishers to figure out like who would be taking it up. So this is more like it's still in sort of like the table of contents.
Mm.
stage at the moment. But yeah, but so I haven't really paused my writing to sort of wait for the publishers. I'm just saying, you know what? I'm just going to keep writing as my ideas start flowing in. And then maybe eventually it will kind of like converge to, okay, the publisher's ready, I'm ready, and then kind of meet in the middle. So you're probably looking at like late 2025 or early 2026 release.
Nice. Well, yeah, maybe we can have you back on for 20 minutes
Yeah,
to do a live release. Cool. Okay, thank you. And the last part, just a little bit of fun, Shreesha.
sure.
Also, just having lots of people like yourself who are, really well accomplished in AI leadership. And I'd just like to ask kind of what AI tools they're using in their kind of work life and, everyday life to be squeeze that extra bit of productivity out of each day of workday.
For sure. For sure. I'm still, I guess I have a little bit of FOMO in not using or not being able to use all the tools out there, but the ones that I use the most often are, of course, like the Copilot capabilities in the VS Code. So writing unit tests or literally just feeding in a very advanced paper and say, hey, convert this to code, and that serves as a starting template or structuring the projects better, right? So that's super helpful. And then ChatGPT deep research I've used very extensively to do like literature review, find the state of the art papers out there, do some compare and contrast, end up asking to like deep dive. So it takes me like hours and hours. It does that in like 15 minutes. And now I have to just go out
Yeah. And
and
how accurate do you find the deep research? Yeah, obviously you've got the subject
yeah.
matter
Yeah.
to be able to challenge it. How accurate do you find it?
So that's a very interesting question. I think the more I feel like the accuracy drops off the longer the conversation goes. So if I just start off with like a fresh instance of deep research and have like one or two prompts, the the results are extremely good.
Yes.
They're mostly summarized from the state of the art. But once I start going kind of like, okay, you have a multi-time conversation, I kind of ask it follow-up questions. Can you kind of investigate this a little bit more? Now it starts getting, I wouldn't necessarily call it hallucination, but it starts mixing up terms because it's not necessarily an expert in recommender systems or personalization. So it makes some assumptions about the article it reads. I think more than accuracy, the one that I find somewhat limiting in some situations is the technical depth of the articles compared to what I can find on my LM. So if you give me Archive Explorer, I can like quickly in maybe like 4 or 5 iterations end up with like a large catalog of very interesting weekend papers to read and then come back with a good amount of literature review. I wish deep research capability would evolve to that, but right now I think there's still some prompts. I haven't really found a pattern of why in some situations the literature review it does is not as deep as I expected, but yeah, it's not 100%, but it's a good starting point for many use cases.
Cool. Okay. And yeah, RecSys obviously LLMs into RecSys is kind of
Yeah.
the next big thing. Like I say, a lot of marketplaces I'm aware of kind of looking at it or already doing it. But where do you see the RecSys market going? I think obviously some of the spotlight's gone on to other topics, but still a great industry to be involved in. Where do you see it heading?
Um, Well, again, these are my personal opinions. I think the impact of LLMs on Rexes is just getting started. So far, as I mentioned, the cost of inference and the speed, the latency of inference has been the two most critical factors in using generative AI LLMs directly in Rexes and personalizations, right? Many of the use cases that I've seen in the industry generally focus on offline product or customer data enrichment, and then using that to then train supervised traditional ML models or deep learning models. Where I think it would be a game changer is one of the two things happen. I mean, both will eventually happen. It's a question of when. The cost, if it goes down further, like let's say 50x, then you end up in a situation where it kind of makes sense to use LLMs everywhere, right? That's not necessarily true right now. And looking at the trends, I was actually doing some review last week on what's the cost curve. I think Anderson Horowitz, the venture capital firm, had a very good graph last year where they've noticed a 10x reduction in cost per million tokens every year, pretty much, right? So if that trend keeps up, which I think it will, we'll probably get there in like a year and a half or so. So it's not unforeseen. The second aspect is the latency part. This is the part that I'm not fully sure when we would reach a stage where, real-time recommendations can happen.
Yes.
It might also be a question of like moving targets as well, but we are still in the realm of like a second to 1 second latency for uh, like large, really large generative AI models that have good accuracy. Of course, you can distill a large language model, get it to like a small container, and then try to do inference, but then you're compromising on the accuracy aspect. So yeah, and like trying to figure out how to get that down. And I think so. I was in the NVIDIA GTC conference in March, and then NVIDIA has like very good infrastructure for like hosting your own LLMs, right? And there might be a trend that we need to keep an eye out. Like they have all the best sort of GPU engineers in the world, and they know how to optimize LLMs to run better on their infrastructure, and then they create those microservices that make it available to people, right? So
Yes.
those are the sort of things that I think would transform recommender systems. Just like figuring out how to incorporate the advantages of reasoning models, generative AI models in the recommendation space. Of course, if you're just building like a conversational search, I think that era is already there. I think a lot of companies are already using conversational chatbots powered by some OpenAI or Gemini API.
Okay, cool. Well, yeah, that wraps everything up for today. Thanks so much for coming on, sharing your knowledge, sharing the RecSys paper, sharing your future predictions, and yeah, I'm sure a lot of people will find some golden nuggets to help with their career or their RecSys projects. So yeah, thanks so much. I appreciate your time and sharing your knowledge.
Wonderful. Thank you, Chris, for setting up this podcast, and love your previous episodes. It covers a wide range of diverse topics, AI, aging, government, BBC speakers. So, yeah, so thanks for bringing me in.
Great, thanks
Wonderful.
so much.
All right. Thank you.